Okay, well, I've had some questions about how I set up my pause button function on my Sega Master System. And it's nothing really all that fancy. The plans for this are available in several places online. There's a couple of different methods to do this. I chose the one that honestly is probably the most complex, but my understanding is gives the best and safest results for the Master System itself. But it does still require modifying a controller, so I thought I would first start this video off by showing the controller itself. There's really nothing too fancy here. Standard Sega Genesis Master System controller. I've taken most of the screws out to make it easier to take this apart later on. Here is the new pause button that I added. It's actually the rubber contact pad from a third-party Genesis controller that never really worked well. It was a really crummy controller, but the soft contact pad underneath the hard buttons on that controller made a perfect surface to actuate the micro switch underneath this, which is the same micro switch that you find on the Atari 7800's buttons. I purchased quite a few of them some time ago from Console 5 to fix actual Atari 7800s for the OVGE show a few years back that I gave away in the show. Anyway, yeah, it works great. It allows me to drill a nice large-sized hole into the controller, which I know some people think that's sacrilegious, I guess, to modify and drill holes into this old technology, but it just really makes it so much functionally better. But yeah, let me show you the controller. So again, nice tactile click. It's soft to the touch, easy to find. The color scheme actually kind of fits in with the rest of it a little bit. It's a little lighter gray, but kind of fits in with that silver of the Sega logo. So it's almost like it was supposed to be there. So I will show you the controller. Let's see here. Okay. And I'll be careful when I open this up. Alright, so if you've ever taken one of these apart before and kind of know what it looks like on the inside, you'll almost immediately notice that several of the standoff posts here and here have been removed. And that was done to allow space for the button I installed and also to allow the wiring itself to kind of act as the spacer that pushes up against the button, holding it in place. So yeah, so let me take this out. We'll get this out of the way for a second. So here's the normal controller. You may or may not have seen them before. And here you can see where one of the standoffs was removed. Actually, honestly, there wasn't anything to it. It looks like I dremelled it. I didn't. I actually just took a pair of needle nose pliers and just went side to side, and it pretty much just snapped off real easy. Same thing with the one on the other side. This is the rubber contact button. I'll take it out so you can see what it looks like. And here we go. So again, this was from a third-party Sega Genesis controller. And what I did was to make it fit better inside the space here, was I trimmed the sides of the button so it would fit nice and neat inside of there. And then there was another standoff originally here as well, but I cut it and bent it out the same way. So that allows me to just set this right inside like that. Pretty much a perfect little fit. And again, the purpose behind this, aside from being a button, is it also gives me the space I needed and gives me a good surface for the actual tactile switch that I had installed, which is on the PCB. That is right here. So here is the normal PCB of a Master System controller. There's your 1 and 2 button locations as well as your cardinal directions for the cross pad. And then this is the tactile switch that I added, which again, if you're familiar with the Atari 7800 and the guts inside of it, this is the same kind of micro switch that is used for the power button, select, reset, all that stuff. Color black and white switch, which is the pause button on a 7800. So how does it all work? Well, there isn't enough wires in a Master System to actually just send the button and just send it to the pause, for lack of a better phrase there. What you do instead is you wire the button up to 2 of the cardinal directions so that when you activate the button, both directions are fired off simultaneously, which is an impossible combination to do on its own but is necessary to trigger a logic gate that is installed inside the master system, which I'll show a little bit later, and that in turn actuates the pause circuit. So it's pretty simple. It doesn't matter which directions you want to use. I think I just chose the left and right directions. But basically what you do is you get your micro switch like I have here, and in this case, this is kind of critical. You need to wire a couple of diodes from each direction point. This is to allow the signal that you've pushed the button to travel through the cable to the console, but not for the directional controls to get confused themselves. Now, what this actually does, or what I will witness on the screen sometimes when using this, is when I push the pause button, occasionally the character might face to the left, or he might randomly face to the right as the game pauses, or when I unpause the game, he might randomly change the facing he was at. On games that don't feature the pause or don't support it, pushing this button will cause the characters to basically shift back and forth left to right like they're dancing. So that's kind of an interesting side effect. But more importantly, it doesn't confuse too much during normal gameplay. So these wires in turn are basically just soldered here to the matching left and right directionals, which in the case of the left and right, it is actually, turn it over, it's a little easier to see because that's where I wired them to. It's here on the top, orange, and here on the yellow where I used the white wire. And yeah, that in turn goes to the diodes. So basically you hit this button, it sends both a left and a right through the cable to the master system's logic, and then that is fed into a logic gate circuit called an OR gate logic circuit that will then trigger and recognize that the two directions have been pushed at the same time, and will then trigger the reset, or not the reset, but the pause command through the console and pause the game. So yeah, that's really all there is to it. This probably actually took me longer to do than anything else because I wanted the wires to be about the right length, and I needed it to sit and fit right inside of the controller, and it was just kind of difficult to get that set up. So I'm going to pause this here and clean this up a little bit and show you the inside of the console. This is, of course, my Sega Master System itself. I apologize for the glare with my overhead light up above, but kind of need it so you can see everything. You can see this Master System has been definitely played and used its life. It's got lots nice little finger prick glares all over it and some scuff marks on it here, but hey, that's because it's been loved. This Master System is also pretty heavily modified, so you'll see when I take the cover off to show you the pause portion of the circuitry modification that there's a lot of additional mods. You can already see in the back here the additional ports, because I do have S-Video, composite, left-right audio on this, and I have a Japanese US region switch here for the FM modification, or the FM board that's been installed. I do have Tim Worthington's awesome FM add-on. So I've already taken the screws out of this SMS to make it a little easier to take it apart. So I'll carefully remove this and get my drink out of the way there. Okay. And I'll try and zoom in here a little bit so we can take a look at things. Okay. And everything's adjustments. So I'm going to talk about the circuit modification itself. It's really not a huge deal, or the circuit itself. The circuit is right here, and the actual circuit that most people recommend you use on this is called a OR gate circuit. And basically, now you have to realize I'm amateur when it comes to electronics theory and the gate logic. But an OR circuit basically says, okay, if I have one input that's true and then I have another input that's true, then the output is a true output. And that is essentially the trick to all this. Remember, I showed on the controller that I am actuating both a left and right directional control. Well, those serve as my two true inputs, which then the logic gate outputs another true out. And in this case, that true out is running along this black wire here, or actually it's this black and gray wire, which when I move back over here, there we go, like that, is wired to the pause switch. So basically when I hit that button on the top of the controller, it goes through this logic gate. This logic gate says, oh hey, I have two conditions that are true, and so the output is true, so I will output a true statement, or I will output a signal in this case, to the pause switch. And when it does that, it's the same thing as hitting the physical pause on the console. And that's essentially how it works. Now, I didn't have an OR gate on hand, and because I have a tendency to, I wouldn't say keep things original, obviously, because I've modified them quite a bit, but what I do try to do is reuse parts from broken video game consoles that I have and use their parts to fix, restore, or modify / improve other consoles. And that's exactly what's been done here. This is not even an OR gate logic chip IC. I didn't have one. But what I did have on hand was a busted up ColecoVision board that has had lots of different parts used off of it. And a ColecoVision, as well as the Atari 5200, by the way, do feature a quad NAND gate IC chip. And the cool thing with the NAND gates is that they are considered universal, in that you can use a multitude or a combination of different NAND gates. There's others too. I think the AND as well can also be used. NOR gates as well. You can use combinations of them to turn them into other gates. And that's exactly what I've done here. This NAND gate, this quad NAND gate, is actually wired underneath it, so that the way a NAND gate works is basically the true statements give you a not true output, for lack of a better phrase. So what you do is you take one directional control and you put it to one of your NAND gates, but you wire it to both inputs on that NAND gate so that you get the opposite output, or the false output, or the negative, or however you want to word it. I'll call it the false and true. So you get like a false output. And then I do it again to one of the other NAND gates on the chip, and that gives me a false output. And then the cool thing about that is if I take those two different false outputs from the two different gates, and remember, this is a quad NAND gate, so it actually has 4 NAND gates inside of it, and I'm using 3 of them for this. If I take the 2 false outputs from 2 of the gates and run each of them into the 2 inputs on a third gate, well, the way a NAND gate works, if 2 true inputs give me a false output, what would you say 2 false outputs give? Well, they give you a true output. So the 2 false outputs from 2 of the NAND gates go into a third, which gives me the true output, and that is what's going to the pause switch. Now, if you're curious, there's different models of the Master System. Some just have little rubber contact push buttons, kind of like on the controllers. Again, this is one of the old styles, so it actually has these leaf switches for the pause and the reset. To figure out which one I needed to attach it to, I just had to take my meter and figure out which of the 2 pins back here ended up going back to pin 22 on the Master System's main IC. And it ended up being the shorter of the 2. And actually it's easier to see because, I don't know if I can zoom in on this. I'll try. Still gonna fight me a little bit. I will move the console then to accommodate. There we go. So essentially, the larger leg here is on a large ground plane. So that was the other way I was able to easily identify which one I needed to connect it to, which was the shorter side. And that's really all there is to it. This really, like I said, didn't take as long to set up and do as the actual controller did. That's because it's pretty well documented on how these gates and how everything else works. So that makes it a lot easier. What other components, or how else does this need to work? Well, in order for a logic gate to function, you still have to have power to it, and it needs a ground to complete the circuit. So almost all the IC chips require a 5-volt power connection. In fact, it seems like almost every modification, amplification circuit, quad amps, everything, it just pretty much always needs 5 volts. In fact, most of the consoles just ran on 5 volts. That's why they had 7805 voltage regulators to provide a 5 volt source throughout the entire system. So what I have done is I have my 5 volts actually wired up over here, marked V3. Turns out that V3, and when you look on the bottom side of this, it's really crazy looking. I thought it was a ground plane at first because it was a huge plane underneath this. Turns out that entire plane is a giant 5 volt rail on the entire system board. So there's actually a lot of places on this you can get 5 volts, but this just happens to be an unused via at V3 that generates 5 volts. And then of course to get your ground, you can just get that from just about anywhere from the edge. And that is exactly what I'm doing here as well. And there is my ground right there. I just ran it through one of the holes like you see here, stamped through the ground plane all the way around the board. I just ran my wire through that and soldered it to that. It works just great. So that's how I got my 5 volts and my ground. Now I have seen other people that are much better at this, especially at soldering skills than myself, that have actually been able to, there we go, they can actually solder that logic gate chip right here. They'll solder their ground off of the ground plane, and then they'll solder the pin for the positive right here off of V3, and then just bend up all the pins they need to use and wire everything else off the top of it. And that's actually probably smarter because it's right close to where it needs to go on the logic side. And so you have less chance of noise and interference interrupting the circuit. But I don't seem to have an issue with that happening on mine, so I'm okay with that. The directional controls also have to be wired in from that controller from the logic gate here. So you'll see that there is an orange and a blue wire, and they actually come off of pins, I'll have to double check here. Let's see if this is 22, 23, 24, 25, 26. Pins 27 and 28 are the player 1 left and right directionals. It didn't really matter which one of these I wired to as long as I had one on one and one on the other, because again, the gates, it's not like it matters, it's just I just need it to give me the right outputs. And yes, you'll see there's other wires and such soldered on. That's for my Japanese switch. So really that's it. That's how it all works. Again, this is one of the easier mods to do. It does require some soldering skills, but yeah, I had a lot of fun doing it and messing around with it, and I definitely love the additional added functionality I have with the console as a whole. So it makes it way easier to play games like Spellcaster and some of the others where using the pause button is almost utilized as an extra button on the, or as an extra button function in the system itself. These are modern times. Most of us play sitting on a comfortable couch or a chair or something to that effect, and you're not sitting or standing right next to the console when you play, so it makes it difficult to have to use the pause button if it's 6-10 feet away from you. Setting up something like this and wiring it directly on the controller just makes it a lot easier and more convenient, and really, honestly, probably should have been designed that way to begin with. So yeah, that's pretty much it. So that's a look into my Master System and my pause button setup, and there you go. So hope you guys enjoyed this. I realize it's real amateur, and I wanted to make another comment about something I just remembered. I didn't specify before, but when I showed the section on the controller and the button that I added for that, 2 of the wires, as I stated, go to the left and right on my particular controller. There is a 3rd wire you have to put in, and that of course has to go to the ground. And so you got to make sure that that's in place. I didn't mention it before, but yeah. So there you go. If there's any questions or want to leave any comments and criticisms, I'm all for it. Yeah, thanks.